Alright, so why the heck do we care? Well, now we're gonna find the derivative of sine of x using the limit definition of a derivative. Oh, you thought this was gone. Well, funny story, really. It never really goes away, unfortunately. It's always gonna be there as your constant little friend in calculus. Alright, so the definition of the derivative, that is the one that says, okay, well, I've got f primed of x is equal to the limit as x approaches, or h approaches 0. Sorry, I looked above and saw x. Of f of x plus h minus f of x all over x plus h minus x, which ends up canceling out my x's, just leaving me with that h. Alright. So now I have got my function, which is sine. So I've got the limit as h goes to 0 of sine of x plus h minus sine of x all over h, which is a fun freaking time. Alright, and then I get to this part and I stress, and then I'm like, oh wait, well, in this last one I had to pull some pre-calc trig identities out of my butt. So now we're going to go ahead and be like, okay, I'm going to use another trig identity. Specifically, this one right here, which is that lovely sum and difference identities, which are the ones that I'm like, hey, you guys don't have to memorize. They do come up occasionally. And this is the occasionally part that I was talking about. I'm not going to make you guys memorize them. But there are some professors that don't want you to be like, hey, I know these. So, doesn't hurt to refresh them. Alright, but anyway, I'm going to say, okay, I've got the limit as h goes to 0 of sine of x times cosine of h, now plus cosine of x times sine of h minus sine of x, sitting there still on the end, just chilling, all over h. Alright, so now what I've actually got to do is I've got to get my sine of x's together, kind of, but not really. So I see that I've got two terms that have sine of x. So I'm going to factor that out of those two terms, which is weird. But I'm still going to do it. I don't know why I just changed to black, but whatever. So I've got limit as h goes to 0 of sine of x. And then what's going to be left is cosine of h minus 1. And then I'm still going to have that plus cosine of x. I don't know why not having parentheses bothers me so much, but it does. Times sine of h all over h. And that allows me to get my sine of x's together and my h's together and away. Alright, this looks like a hot freaking mess, and you're right, it does, but I'm going to break this up a little bit. Oops, I don't know why I clicked that, but alright. I've got the limit as h goes to 0 of sine of x times cosine of h minus 1 all over h plus cosine of x times sine of h all over h. And then I'm going to say, hey, wait a second. Wait a dang second. Didn't we just do like something with a cosine of x minus 1 and a 0 and all that kind of good nonsense? And you're right, yes we did. We said that that whole mess right there is going to go to 0. And then hopefully we're starting to recognize that, hey, I've got a sine of h over h as well. And we did something like that a while back. So I can use these two facts. So now what I've really got is a limit as... I I guess I really just got sine of x if I'm plugging in 0 for h at this point, times 0 plus cosine of x times 1, which 0 times anything is just 0, and then 1 times anything is just the anything. So really all I'm left with is cosine of x. Nifty. Alright, we can prove the derivative of cosine of x is equal to negative sine x using the same method and the same two limits above. Alright, but that's not. I'm not gonna make you guys memorize this. Absolutely not. But I'm just letting you guys know, like, hey, it comes from somewhere. Everything comes from somewhere, whether we like it or not, and it's good to know where. That way we don't have too many whys other than why is it so long. Alright, and that's a fair point, but it is calculus, after all. Alright, find the derivative of tangent using the quotient rule, and the derivative of sine of x and cosine of x is up next.